All right, so here are the notes that we're going to be taking for tonight. The title of the notes is Solving Exponential Equations. So these are our second set of notes because we've done this before. We've solved exponential equations. We used this little handy dandy chart and we were changing bases to do it. Today, we're going to be doing it by taking logs. So by taking logs, okay? So I'm just gonna do a couple example problems. Here's the first one. We're gonna have 11 to the V equals 90. So if we were doing this the other day and we were doing it by changing bases, then we would take this little chart out and we would look and we would say, okay, I'm looking for where 11 and 90 show up in the same column. And there is no stinking way that 11 and 90 are going to show up in the same column. It just doesn't happen. And so what we're looking to do instead then is we want to undo this base of 11 so that the exponent v can be freed up so that it won't have that base of 11 there because the variable is what we want to solve for. So I talked to you guys the other day about inverse operations, add and subtract, multiply and divide, square and square root. And I said that the newest inverse operation that we had is logs and exponents. So if we have an exponential equation with a base of 11, and we want to undo that base of 11, then what we're going to do is we're going to log base 11 each side. What I'm going to do is I'm going to rewrite this. I'm just going to leave a little bit more space this time. So 11 to the v equals, I'm going to leave some space, 90. So we're going to log base 11 and log base 11. So I did log base 11 on each side. Now, since these are inverses, they cancel each other out. So just like add and subtract are inverses, if you have plus 3 and minus 3, those two things cancel. Multiply by 2 and divide by 2, those two things cancel. Exponent with base of 11 and log with base of 11, those two things cancel. So we get v equals log base 11 of 90. Now, this is considered to be the exact answer, but most of us do not think in terms of logs. Most of us think in terms of decimals or fractions or whatever. So I'm going to go ahead and go to my Desmos calculator and type that in and see what that decimal is because it'll make more sense to my brain. So log base 11 of 90. Remember to get that base in there. We're thinking of doing a subscript or an underscore. And so V is approximately 1.87, the 6 is followed by a 5, so 1.877. So both of those answers are good. I have my exact answer. I have my approximate answer. I'm doing a squiggly equal sign for my approximate answer to show that I rounded that before I wrote it on my paper. Okay. Let's do a problem that's a little bit more complicated. We're gonna do, and by a little bit more, I'm gonna mean a lot more, but I think you guys can handle it. Okay, so just like when we have solved equations in the past, we're going to undo the order of operations. That's how we're gonna do the steps. So our first step is going to be what can we add or subtract easily to the other side to get it away from the variable. And the variable's right here. There's the k. So we're thinking, what could I add or subtract easily? Well, the 2 on the end, that's easy to deal with. So I'm going to go ahead and do the inverse. I'm going to add 2. I get 3 times 12 to the negative 4k equals 75. That was easy, right? The next step, is there something I could easily multiply or divide to the other side to get closer to the variable being alone. Here's my variable. Something that would be easy to multiply or divide is that 3. I'm going to divide by the 3. That's easy to do. All right, so now I've got 12 to the negative 4k equals 25. All right, next we deal with stuff that have to do with our exponents. So here is when we say, okay, my variable is in the exponent. That's what I'm trying to get at. So I need to get rid of this base somehow. And the way that I get rid of the base now is I remember that the opposite of a base of 12 is log base 12. So I'm going to go ahead and I'm going to log base 12 this side, and I'm going to log base 12 that side. So now log base 12 and base 12 cancel out. Those are opposites of each other. They cancel out. So I have negative 4k equals log base 12 of 25. All right. And then last, we always have parentheses. What they meant by parentheses is grouping symbols, whatever was grouped or whatever we called it, like inside. Do you like my air quotes? Inside. And we know that when we talk about exponential functions, the inside of the function is always the exponent. So at this point, we're technically inside the function, even though it's not really parentheses. So we're going to say inside. This is just inside the function. We are inside the exponent. And so at this point, we're ready to get k by itself. We can divide by negative 4. So the exact answer to this problem is log base 12 of 25, all divided by negative 4. That's the exact answer. I'm going to go ahead and put a box around it so we can actually see it. And that's a very funky looking answer for pretty much everyone. So let's go ahead and go on Desmos and type that in. I've got log underscore 12, 25. Then I want to hit divide by. There we go. It popped it down. Divided by negative 4. Okay, so k is approximately negative 0.324. Okay, let's try one more. All right, 4 times 3 to the a plus 6 minus 7 equals 4. Okay. First thing, what can we easily add or subtract to get it away from the variables? The variable's right here. What can we easily add or subtract? I've got a 7 that's subtracted on the end. I'm going to go ahead and add that over. All right, next step. What could I easily multiply or divide to the other side to get my variable alone? So I've got a 4 there. I could divide by 4. All right, now this is about to not be pretty because that's a fraction and that's going to stay a fraction. Okay, I've got 3 to the a plus 6 equals this fraction. I'm just going to leave it like that. Okay. Now I've got an exponent that I'm trying to get at. My variable's in my exponent, and I have a base of 3 that's in the way. So to undo that base of 3, I need to log base 3 each side. Log base 3. So the log base 3 cancels the base of 3. And then I have a plus 6 equals log base 3. I'm going to put this in parentheses just so I don't get confused. Log base 3 of that fraction. All right. Now, these aren't really parentheses, right? I mean, you can think of them as parentheses as you want, but that was kind of like the inside of the exponential function. So now we're inside, and now to get the variable alone, I just need to take that 6 and subtract it over. I'm just going to subtract it off the end. So my exact answer is log base 3 of 11 over 4 with a minus 6 on the end. That's my perfect answer. And then to get my approximate answer, I'm going to go ahead and type that in on Desmos. So I've got log base 3 of 11 over 4. Oops, I had some extra parentheses I didn't need, with a minus 6 on the end. So A is approximately negative 5.079. And that is my approximate answer. I'll go ahead and show you what I wrote. I did a little squiggly equal sign right there. All right, so now we are done with the notes. The next thing you're going to want to do is to go and here, go down to where it says homework notes. This is where this video will have shown up. That's where you could have gone to take the video. And then you're going to take a picture of your notes and upload them right here. So that's the next thing you're going to do tonight at midnight.